Okay, well, it doesn't take a rocket scientist to figure out what today's topic is going to be about. I have a job where I need to create a slitting saw arbor for a very specific application. Now, as you can see, these saws, they come in a variety of different shapes, different grinds, different profiles, staggered tooth, straight, small, 1-inch keyed, half-inch diameter not keyed, and probably not keyed, because if this saw were to grab, it's just going to explode because there's basically nothing there. It is very thin. Although they look flat, these are actually hollow ground, which means they are dished or taper ground. Not by much, but enough to keep the saw from rubbing as it progresses into the part. And we have an arbor here in the back. I'm going to make a combination of this particular arbor and this little guy back here. These are two different styles. This one is telescopic, as you can see, very low profile, which is good because a lot of these have a big ugly nut on the outside, and sometimes that is a problem. So a low profile arbor like this, in my opinion, is preferred. For my applications, it's preferred. You make your own choice. This is very much like a drawbar. Well, it's exactly what it is. It's a drawbar in the back. As you tighten this up, this draws in and cinches up on the blade. This particular style is also a very homemade item. Holds onto the blade. Little cap with a counter bore. Locates on the remaining projection from the arbor. Keeps it centered, and a flathead screw draws it down. Well, I need that style back there in this size. So let's grab a piece of material off the shelf and make that happen. It's going to be a 1/2-inch locating feature. It's not going to be a boss, at least not on here. We're going to reverse it. We're going to make the boss on the cap. So the saw will install onto the cap. The cap will then install into the arbor. And I'm not sure if I'm going to draw it down from behind or from the front. Using a flathead screw, you are going to compromise the size of the Allen key that you are allowed to use. Flathead screws are historically smaller than a cap screw. So if you're looking to get any kind of torque out of your arbor, make sure you think about that first. And since this is a 1/2-inch through hole, I could probably use a number 10 or a 1/4 inch and just recess it into the cap and have an extremely low profile bite to get the job done. You can also come in from the back if you want. Okay, let's grab a piece of 3/4 inch stainless off the shelf, because that's what I have, and let's make an arbor. We are starting with a piece of 3/4 inch diameter. I believe this is 3/16 stainless, about 4.5 inches long. I'm going to do the cap first. Actual start time, 20 minutes to 11. Starting with the cap, the initial diameter that you turn should match the ID of the saw that you are going to use very closely. Any difference in the OD versus the ID or the OD of the cap to the saw is going to lead to an eccentricity, and you're going to get that chewing sound when the saw engages the material. Although anybody that ever uses a slitting saw, if something is running smooth, you got to believe something's wrong. So let's turn this down to 5/8 by about 5/8 to 3/4 long. Pop a 257 diameter hole through the center of it and part it off. The ideal way to start any piece is with a nice clean face. Gives us a registration surface, a little scuff on the outside to set the tool. I know basically I'm going to be taking about 1.5 millimeters off of each side of this, so once I register the tool, I can just rough the dial in and away we go. I am looking for 15.875 millimeters on this diameter. That's a 625 American Imperial conversion. Stainless steel does get hot, so be very cautious of the temperature of the part. This material will heat up and swell up, and if you check it while it's hot, you're going to be very disappointed once it cools back down. A very fine pass for the finished cut, and away we go. Fits the saw just perfectly. Now you need to realize and pay attention to the radius on the tool that you've selected for your first operation, and go in there with a second tool and knock that radius out. The transition between the small diameter and the large diameter, right there in the corner, right there, that radius has to go. I am looking straight down on top of the tool right now with a jeweler's loop, setting the tool. If there's any undercut to be made, make sure it's on the face of the transition between the two diameters and not the smaller diameter. If you use an exceptionally thin saw, the saw could register inside that undercut and cause an eccentricity at the machining operation. Although it doesn't look like I'm moving, I am moving very slowly, and that's all done under magnification. And you can see the radius going away. A little bump on the back side of the deburring tool for a nice lead, because this will be a sliding component. .400 emery just to take the tool feel off. This isn't really doing much of anything, but it is taking off the high spots. And of course it's got to be pretty. Moving on to the center drill, 3/16 stainless is something that's just a pain in the neck to drill. Lubrication is a really good idea. And once the chip starts flowing, keep the cut going. That's one of my rules of thumb. If you sit on 3/16 or 3/04 for too long, it is going to work hard on you. So if you got a nice chip pouring out of the hole, just keep pushing it. This is a 6.527 millimeter drill. Imperial is a 257. Just a little bit bigger than the screw you're going to use. So if you're going to use a 6 millimeter screw, drill it accordingly. This is going to be a 1/4 screw, so it's just a little bit over. Light touch up on any burrs that may be present. Once again with the saw, everything is perfect. You know when it starts to rock back and forth like that and hang up that you got a good fit. Little fast forward on the part job here. Trust me, it doesn't fall off that quick. It might on a screw machine, but not on this one. Pre-drilling the bore for the Arbor now. The cap is set aside. I will pilot drill the end of the Arbor slightly deeper than the length of the cap. That way I don't have to worry about boring a flat bottom hole. And I know that the roughed out material is deeper than the boring bar will go, so the boring operation should be relatively smooth. After you rough out the end of the Arbor, we're going to pilot drill through for the 1/4 tap. And I am going to go slightly oversized with the drill. I'll mention that again, but slightly oversized with the drill. And I'm going about 1.5 inches or so deep. I want to make sure that the hole is much deeper than I really want. Flip the part around, and I'm going to come in from behind with a larger drill. Now there's a reason for this. If you take the overall length of the Arbor minus the depth of the front bore where the cap is going to fit, minus however much thread you want, that will give you the value of how deep to put this rear hole in. By having a through hole as opposed to a very deep bottom tapped Arbor hole, that allows you to use a very long screw on the cap and gives you a much wider range of grip ability for whatever saw you decide to use. And once you see the assembly, it'll make a lot more sense. And sorry about the autofocus. The autofocus gremlins were alive and well while I was filming this. And you can see that anchor loop does not like to stay put on a hot surface. So do yourself a favor and put it down inside the hole if you want to continue to use that once your drill gets hot. As much as I like it, I had to switch back to WD-40. And there's the gremlins one more time. They will go away, so hang in there. Once you break through to the pilot hole, the drill moves a whole lot easier. Make sure it's nice and cool before you touch it, because I can tell you, pushing a hole drill that deep, it's going to be hot. Let's flip it back around and work on the working end. With the pilot hole for the tap drilled slightly oversized because of the material that I'm using, let's see if we can chase some threads in there without snapping the tap off. Okay, force of habit, guys. I know I said chasing the threads. It's not. I'm actually tapping the threads. And stainless is something you got to just get a feel for. It can be quite fussy. It's a very grippy material. And it did take a little bit longer than this video represents to tap this hole. The anchor lube is a great idea. It's a good lubrication for stainless. Make sure you wipe it off of your machine, or it will stain the ways and whatever other metal surfaces it touches. Before I start any final features on my parts, I like to make sure that everything is nice and clean. So I'll take the collet out, I'll flush the collet out, blow it out, wipe out the taper on the inside of the nose. Only takes a minute. It just guarantees that you've done everything you can to assure that you'll get the precision that you're looking for. The part has been pre-bored, so it's not quite the 625 that we're looking for. I'm only going to stick it in the collet about an inch. I'm going to try to replicate the extension of this arbor in the lathe the way it will sit in the mill. And before I assume that anything is going to run true, we're going to indicate it. Once you're sure that two locations, indicated out at the end and indicated right up at the collet. As soon as you have both of those locations zeroed out or close that you're okay with what you're seeing, and by all means proceed with the final machining operations. This is running about 3/10, give or take. Same with the collet. So we can assure that this is pretty much spot on. Moving to the final boring operation. With it extended like this in a thin wall that we are boring, or that I am boring, you can expect a little bit of noise. It's very possible that it could chatter, sing, ring. I put my finger on the outside of the tube as a damper. If it starts to make noise, chances are the harmonics will keep it going. So if you can break the rhythm by putting something on the outside, wrapping it with a rubber band can sometimes work on a thin wall. I've also seen guys use bicycle inner tubes. Wrap it up and tape it, and the inner tube will absorb the harmony and shut down the noise and give you a better finish on the inside, believe it or not. Anytime you're machining stainless, you have to be very aware of the heat, especially on a thin wall like this. As a thin wall like this gets hot, it will react a lot faster than a thicker cross-section part. And I was just the temperature check right there. Nice sharp tool is important. Keep it nice and cool before you do your test fit. Do not put the part in and walk away. If it's got any kind of heat to it, when you come back, it's going to be one solid piece like a frozen shrink fit. So make sure that everything is room temperature before you start messing around with gauges or mating parts. Once you're happy, clean it up. ID and OD, 3-corner scraper for the inside. I love those tools, they are great. 400 emery on the end of a G10 stick, wiping out the burrs, wiping out the dust. And face off the end. Make sure that if you're going to bore it with it extended like this, that you face it off extended like this too. You want to make sure that all the features are true to each other. Clean up the OD, make it look pretty. Wipe off the debris, flip it around, do the other side. There you go. Okay, let's put a collet in there the same size as the diameter of the saw ID, 5/8. This facing pass will determine the projection of the arbor. So however thick you make this head right now will be the clearance that you'll have below the saw. Don't make it so thin that whatever screw or hardware that you decide to use distorts it under pressure. So you want to balance out your design a little bit. This boring bar is being used specifically just to make a counter bore for the cap screw being used. And this cut here just started to scream a little bit on the way in, so I'm going to back it off a little bit and do it in 2 passes. And go back in and make sure that the bottom is flat with a draw pass. 3-corner scraper on the corner, and we are done. Finish time 11:45. A quick bench review of the features. Make sure that the cap that you make fits just perfectly inside the saw. This will determine the concentricity or assist in the concentricity. This inside corner right here has to be nice and sharp because, as you can see, there's no radius on these saws. They are just spot on. And this is carbide, so if there's anything going on and you squeeze down on it, it's going to blow up. Make sure that the cap fits inside the bore really smooth. Make sure that the bore is deeper than the length of the cap. Okay, bore it just a little bit extra, or bore it the same. It really doesn't matter because you know you're going to have a saw in there, right? There you go. I drilled a larger hole in the back of the arbor so that I didn't have to worry about how many threads were down in there. There's about 400 thousandths worth of thread, maybe 10 millimeters worth of thread. I used a cap screw instead of a flathead screw so I can use a much larger driver. And when you assemble these, you want to make sure that the teeth are facing as if this was a screw, as if this whole thing was one piece. When you turn it in, you want to be forcing against the face of the teeth. That way, if it grabs, it just gets tighter and does not unloosen. Here it is. Let's see. Okay, you can see I'm turning this clockwise to lock it down. The resistance on this saw will also be clockwise, so as you use this, as you abuse this, it is only going to get tighter. There you go, super low profile. You can get right up against whatever you're doing. If you wanted to, you could also tap the cap and bring a long screw in from behind. The disadvantage to that is you will have to remove the arbor from the machine to then change the saw blades. So bear in mind what you're going to be doing, what your restrictions are, what your needs are, and do it accordingly. Let's pop this in a milk collet, fire it up, see how true it runs. That was a good still right there. Let's shoot that as a still. Okay, concentricity test. We are on a 3/4 collet in the mill. And there is a scuff mark on top of this saw that will make this look like it's running out excessively. Watch this area right here. And I'm going to get it real close to the material as well, and we'll see just how much it is running out. Watch the bump. You can see that scuff that comes around. Let's see what happens. Alright, a little different camera angle here. We can creep up on this piece of aluminum, and I just want to show you how close you can get that without this chewing and grinding and running out. The concentricity of this saw right now is absolutely spot on. If there were any error in the way this was running, I would blame it on the saw because the Arbor came out quite well. Mr. Autofocus drops by to say hello. And there you go. That's a great little project you can do, and it's something that'll pay dividends for a very long time. Thank you to all my new patrons. I will be upgrading my camera shortly, so you don't have to worry about this anymore. Thanks for watching, guys, and stay well.